All right, good morning, everybody. So I thought I would just do a quick kind of rigging walkthrough to see, where we are, starting with joints and going all the way through to controls. I'm going to do this actually just for the left arm here, just to kind of keep it focused and try to get through a lot of content in a relatively short period of time. And so in any case, let's go ahead and let's go ahead and jump in. So the first thing, whenever you're considering rigging a character, you have to take a few things into consideration. The first is the pose and the anatomy. The pose, the anatomy, and then of course the things that your character is going to need to do, because that will inform you on what kind of joints to create and how to lay out the controls and all that kind of stuff. So for this spy, we're going to keep it really, really simple, bare minimum, and probably here for the arm, we probably don't need a whole lot of structure. I'm actually going to do the spine first and then go into the arm because I always start with the spine. And so let's go ahead and get started. So when you create your joints, it's beneficial to create them in a orthogonal view. It's just easier to kind of control where they go and how they're oriented. And so let's just lay out the first joints, and then we'll talk about orientation. So when you go to skeleton, you can say create joints. I'm going to click the options box. It's easier for me to say, isn't it? And I'm going to just reset the tool. We can just leave all this as is. And then I'm going to start with what I call the root joint. And the root joint for me is it's the joint that all the other joints connect to, or chain off of. So generally the root will be kind of where we kind of think the center of balance is for us. And when you create joints, for the most part, you try to make sure that it is within the center mass of the geometry. So with this being the front and this being the back, you want to try and get it pretty close to the middle. So I'm going to click, when I create joints, once you have the joint creation tool selected, you just click and you see that tiny, tiny dot right there. You know what, let me change this because that's really small. Just so that it's easier to see. I'm going to go to animation or display animation, joint size, and I'm just going to crank that up to 10. And then let's try that again. Hopefully it's a little bit more visible. So I'm going to click there. There we go. Now you can see it. And then I'm going to select, again, I'm just doing the spine. So I'm going to create the first joint, and then the last joint is going to be up here at the base of the neck. And so I'm going to just click here. Also, ooh, that's really big. And then I could actually create the very last joint in the spine. I could just go on from there. Why not do that? And this is going to be a Terminator joint. And the Terminator joints actually lie outside of the mesh. You don't want them inside the mesh at all. So I'm going to select, now you can see these really massive joints. Let me go ahead and go to display animation. I'm going to dial those joints back down. So I'm going to just dial it down a little bit so that they're not humongous. And here we go. And I'm going to go ahead and add them to a layer. So I'm going to create this, or create a layer and add those objects to it. I'll just call this layer underscore joints. And I'll make it something really green so that we can see them. Also, whenever you're looking at your mesh or looking at your rig in perspective view, there's this little button right up here, which is basically X-ray joints. If you turn that on, you can see your mesh as a smooth solid, but your joints show through it. I like this a lot. If you go into just like pure X-ray, oops, is that the right one? There we go. It looks kind of holographic and can get messy, especially when you've got a lot of layered geometry. So this is a little bit easier way of seeing your stuff. So I'm going to go ahead and select. So the thing that I need to see is, now that I've kind of laid out those initial joints, I need to see how they're oriented, and I want to see if that is how I want them to be, either if they meet certain technical specifications, or if I just like to rig in a certain way. So I'm going to select the root joint there that I just select, the first joint that I created. I'm going to go ahead, select hierarchy, and then I'm going to say display, transform display, local rotation axes. And this shows me how they are oriented, right? So we have our world orientation down here in the lower left, which shows you the world coordinate system, X, Y, and Z. But as you probably know, objects have their own local coordinate system. And so local coordinate systems are what we're looking at here with the joints, right? So in this particular instance, as a matter of fact, I'm going to turn my geometry to reference so that I don't have to, I don't click it by mistake. So you can see, like for this particular joint, Z is actually facing this way, Y is facing this way, and X is pointing to the child. You can see when I created these joints in Maya, in Outliner, you can see joint 1, joint 2, and joint 3. So you can see that joint 1, the X local the X local axis is actually pointing to its child. Now this is called the primary axis. This is really, really critical that it is always consistent. When we get into moving joints around, you'll notice that, well, I'll just do this really quick. So if I say, for example, the thing you want to be careful of is when you are moving joints that you just need to be aware. And so you can avoid this, but you can see how X for this joint is pointing directly at its child. Well, let's just say, for example, I decided I wanted to move this joint over here. Well, you can see the bone seems to be pointing to the child, but if you look at the joint axis, it hasn't moved. It's stayed the same. So these joints are now out of alignment because these aren't oriented correctly, because they're no longer, this primary axis is no longer pointing to the child. So there are ways of getting around that, but I prefer to avoid that if at all possible. And we'll talk about how to avoid that when I get to the arm. So, but one of the things you can also see is, so I have my primary axis. My secondary axis is kind of what I refer to as like the sort of the primary axis of motion. So for the spine, your spine can move left, from side to side, but it moves, I think, well, to me, it just makes, it makes sense that the spine moves forward more than it does. It's sort of axis of rotation is far more forward than it is backwards or side to side. So I'm going to consider the rotation in this direction to be sort of its primary, or its the main direction that it rotates in, and that's going to be your secondary axis, which will be, now you can choose Z or Y. The thing though is that it has to stay consistent. So if this one is Z, or if I choose Z as my secondary axis, this one also has to be Z as my secondary axis, and so forth. So I'm just going to stick with this. But you notice like here, if I select this joint and I rotate on the Z axis on the positive, it bends forward, which is great. That's kind of what I want. But if I select the neck, you see how the Z axis is facing the other way. If I rotate on the Z here, on a positive, you see it actually bends backwards. So these are also, this joint is now, it doesn't follow my schema. So I have to change that. And for the orientation, I'm just going to go to skeleton, orient joint. And we already talked about our primary axis is X. So that one stays the same. As I mentioned here, my secondary axis is going to be my Z axis. So I'm going to select that. And then what I'm, this last setting is, it's asking me which world coordinate, you can actually see it says right there, which direction do I want my Z axis to go into? So down here, Z is pointing in the positive X. And I'm just going to follow that because I want any positive rotations to be adductive movement. Anything away, or a negative rotation, I should say, should be an adduct or an abductive, ABDUC, an abductive motion. So I'm going to say, so primary axis is X, secondary axis is Z, and I want it to point in the positive X, just like this one is. And again, it's the positive world X, not local X. So I'm going to select that joint, change this to positive, and if I hit apply, you can now see that this joint now follows the schema of my root joint. And my Terminator joint doesn't, since it's not actually going to be affecting how the rest of the joints work, I don't really need to orient this one. But just because attention to detail is very important, especially when you're talking about so your technical disciplines. And actually, it's not a bad idea to get in the habit of this for later things. So what we can do is to orient this. You could say, well, why don't I just use the same settings? And I click apply. You notice nothing happens. And the reason is because the primary axis is relative to the child. So when I say primary, when I orient this joint and it says the primary axis, it says, okay, my x-axis needs to point to my child. The Terminators don't have child objects, so there's nothing to orient to. When that happens, we get to fall back on the other orientation sort of process that Maya has, in that children gain their understanding of their world orientation from their parent objects. So what I mean to say is, if I select this Terminator joint and I say orient joint to world, now you'd think that it's going to orient to the world axes down here in the lower left-hand corner. But to this child, its parent is its reference for world coordinates. So, oh, hang on just 1 second. Okay, so as I was mentioning, this child object will derive its world orientation from its parents. So if I say orient joint to world and I click apply, you can see how it's snapped. It basically is following the orientation of the parent joint. So let me name these really quick because you definitely want to get in the habit of that. Joint 1 is actually going to be, oh yeah, let me show you a really quick way of, you can select your joints either by control clicking them in the outliner. You can select the top one, shift select the last one. That's another way, or you can just try and, I don't recommend like marquee selecting in your viewer because if you've got a lot of joints, it could select them in weird orders. So here's what I'm going to do. I'm going to go ahead and go up here and say rename. And I'm just going to lay out the basic naming convention. So actually, none of these follow the same one. So I'm just going to leave this with JNT underscore. And I guess let me hide my floating controls. There we go. It's joint. I'm just going to leave it that way. And I'm going to hit enter. And you can see here, it already added my prefix in. So I'm going to double click and just say root. Then I'm going to say, this is going to be actually my last spine joint. The base here, I'm going to refer to it as the spine, not the neck. So I'm going to just call this spine. Then I'm going to say X for now, because I don't know how many spine joints I'm going to create in between those. And we'll talk about that here in a second. So spine underscore X. And then this is actually going to be my head terminator joint. So I'm going to say joint underscore head underscore T. And so now what we've got is we've got our joints. They're added to our joint layer. They've been named. We know we have a schema now, an orientation schema that we know we can follow with the rest of the rig. So now you notice, like for the spine, we've only got one at the bottom and one at the top. There's not a lot of or any really articulation there in the middle. So what we're going to do is use the insert joint tool to add some joints to our model. Now, I'm going to do this in the front view, and I'm going to turn on wireframe, because your wireframe helps inform you where your joints kind of need to go. The other thing to keep in mind is that you try to keep your joints evenly spaced between each other, so that the articulation is smooth and you're not putting a lot of distortion on any sort of one set of geometry. So to put joints between these two, I'm going to actually go into skeleton. I'm going to say insert joints. And when I use the insert joint tool, I'm going to click on the sort of base joint and just drag up. So click and hold down, and you can just drag it up and down the chain as much as you want. Now, what you could do is just kind of split the difference here, and then maybe add another one here between the two. That's, I don't think, unreasonable. And we'll just do it that way. So what I've basically done is I split the difference between these two, then I split the difference between those. And the cool thing about using the Orient or the insert joint tool is that if I go back into my perspective view, now I'm going to have to turn on local rotation axes for these joints as well, because it's a toggle and they don't inherit that. They don't inherit those settings. So I can go in here and just select these joints and then say, again, display, transform display local rotation axes. But the cool thing is that when you use the insert joint tool, they inherit the orientation. So, I mean, as long as you don't have anything changing like we will with the arm, this is a really great way to kind of make sure that your joints are perfectly oriented with each other. And so now I'm actually going to go into the side view so I can do the head part. And so as a matter of fact, let me rename these as well. So because I didn't know like how many spines I was going to have, you can see that this is spine X. I'm going to control click joint 3, go to joint 1, 2, and then my last one. So I basically select them down the spine. So in order matters. So again, 3, 1, 2, and then this top one up here. And I'm going to do the exact same thing I did before: joint, spine. So one of the things you'll notice is it's already got, actually, I think this will be fine. Let's see what happens. If I mess it up, at least you'll see what happens. So I'm going to hit enter. And you can see that because I just had joint spine underscore, it does the naming for me. And that can save you a lot of time. Now we're going to do the head. And I'm going to use, again, the insert joint tool. Going to click here, drag up. And I try to get the head joint right about where the eyes are. Now, it doesn't really matter where in the head that this head joint resides, but kind of roughly where the eyes are is good, because we may have other joints in here, and having it maybe a little bit higher than maybe dead center of the head will help kind of keep joint layout clean. So this will be the head joint. You can see it get created here in the outliner. I also need a neck joint. And so I need a neck joint that's going to live dead center of the neck. And so I'm just going to go in and do the insert joint again and put the crosshairs of this joint right in the center mass of this neck. So I'm going to hit the enter key to tell Maya that I'm done with all this business. And now I need to go in, and you can see here it's starting to get a little busy. So I'm going to go ahead and select my entire root chain, select hierarchy, and I'm going to change the radius to something a little smaller so it's easier to see. And then, because I cranked up my display for joints to be so big, oh, well, it's actually not too bad. Actually, I'll just do one. And then I'm going to go in and change my radius here so that there we go. So now you can see my joints, and you can get a sense of where they are. Again, like once they're done, you got to name them. So this is going to be my neck. And I'm just going to, because I'm lazy, I'm going to copy this. Double click, joint underscore neck. And then I've got this one here, which is my head, which I created. Joint underscore head, enter. All right. So, and again, because we use the insert joints tool, if I select both of these, go to display, transform, local rotation axes, you can see that they all follow the schema, the primary axis, the secondary axis. And if I select the whole chain, the whole hierarchy, right? And I rotate on the Z in a positive, whoops, that's not positive. In a positive, you see they curl. That means they're all aligned the way they need to be. A negative brings them back, a positive brings them forward. So that's in keeping with my design. So the next thing we need to do is move on to the arm. Now the arm's tricky because you can see, whoops, sorry, this keeps popping back and forth on you. You can see that the arm doesn't go straight out. The benefit that we had with the spine is that it's kind of straight. Pretty easy to set that up. Because the arm starts off going straight, so it'll go from, we'll start with a clavicle, and then we'll go to the shoulder, then we'll go to the elbow, then we're going to go to the wrist. But you can see not only does it start off straight and then go down, but it's also bent in the middle. And so that can be problematic, and very easy to get your alignment, to botch your joint alignment. So this is kind of where, because as I mentioned, like if you move a joint, it goes out of alignment. And I'll show you. Let's just walk through it. So let's just say I decided to create this in my front view. And I go to skeleton, and I go to create joints, and I start with a clavicle, and then I go, whoops, hang on a second. This is not skeleton, create joints, short bone radius. Let's just say I'm going to do all of this here. That's still pretty small. Let's just do 2 and 2. That's better. Actually, let's just do 3 and 3. All right, so I'm just doing is creating these, making so that these joints are a little bit more visible. So I'm going to start with the clavicle, and then I'm going to go to the shoulder, which needs to be pretty close to center in this, where the shoulder area is. So right about there. Whoa, it's a little bigger than what I wanted. Let's just stick with 1. All right, so I'm going to click to there. I'm going to click to there. That's still huge. 0.5. All right, so there, it's really tiny. Sorry about that. Boom. Anyway, we'll figure it out. So there's the shoulder joint. There's no problem seeing them at least. And then click in the shoulder, and then click in the wrist area. And then I'm gonna hit enter to say that I'm done. I'm gonna definitely make these. Even though it looks like they're all selected, I've only got the one selected. So I've got, I have a button here to that I created to select the hierarchy. So I'm going to select that, and yeah, I'm going to change this to 2. There we go. So even though, and selected joints, even though they are aligned on the from the front view, from the side, obviously that they aren't. So I've got buttons up here to help make this process go a little bit faster. So I selected the hierarchy. I'm going to toggle the local rotation axes. I'm going to just move this clavicle into place, which isn't too far off. And you can see here, though, that the shoulder isn't quite aligned. So again, like I mentioned, your instinct might be to grab that shoulder and move it into place, but watch what happens with the X axis for the clavicle when I move this into place. You see, it doesn't follow it by default. Now, there is a setting here that says automatically orient joints. Don't use this, because if you use this, then what's going to happen is it's going to orient your joints to these settings rather than kind of how you want that. So don't you're going to be tempted to, but don't use it. So so what we do instead is we'd use a different method. And but before we start moving anything, we need to first determine whether or not these joints follow our schema for joint orientation. So we know X does, right? I mean, it's by default, Maya sets that up for you. So we know X is pretty good. So again, our secondary, if we look at our spine again, our secondary rotation axis is Z. And for the collarbone, that makes sense, right? The collarbone's job is to rotate the shoulder up and down. And but let's see if it's oriented in the right direction. So if I select rotate Z, if I give it a positive though, you see it is abducting, A-B-D-U-C-T, abducting away from the body. I want this to be the other way. And so what I'm going to do is I've got to use the rotation tool. So I'm going to go to skeleton, orient joints, options, primary axis, always X. Secondary axis is always going to be my Z axis. And then it's asking me what world orientation do I want it to follow. And so since I know that, pardon me, since I know that the positive Z is it's sorry, the axis that it rotates on is correct, right? Z is correct, but it is the wrong orientation. So it needs to be facing in the opposite direction. I also know that nearly all of my joints will be following very similar orientations. So I'm going to select orient children of selected joints. So in any case, X is my primary, Z is my secondary, and since it is currently facing the positive Z world axis, I want to face the negative Z world axis. So I'll select Z here for my secondary axis world orientation, and I'm going to select negative. And then I'm going to click apply. And you can see now that the Z is now facing the negative world Z axis. And then I'm going to click close. And now if I again do my rotate, a positive rotation brings it in to the body, which is what we want, and a negative brings it away. So this is following the right orientation schema. Same thing with my my shoulder, sorry. Positive brings it in, negative is away. That's good. And then my elbow, though, is kind of an interesting thing, right? Because the elbow doesn't rotate like this, right? It rotates like this. And so what I need to do is get it so that the Z axis is actually facing where the Y axis is, because you can see like it's supposed to be bending like this on the Y. So again, I'm going to break out my, this isn't actually, I don't think I explained that well, that could get confusing. So you can see the local rotation axes for this joint. Z is facing towards the back, like the shoulder is, but the shoulder, that works fine because the shoulder does rotate this way. It does these other directions too, but that's kind of what I consider its sort of primary range of motion. The elbow, though, rotates forward. It doesn't go side to side. It's not a ball joint like the shoulder is. So I need to make the Z axis point in the direction like a hinge on a door. I need to point in the direction that the joint rotates off of. So if you're looking at this, it's kind of where the Y is. So I'm going to say Windows or skeleton, sorry, Orient Joint, click my options box. All this stuff can stay the same, except if I'm looking at this joint, that is the negative Y, or that's the negative X world axis here. So I'm going to turn off Orient Children. I don't want that. And my Z axis is still my secondary axis, but I want it to point in the negative X. So I'll hit apply. And now let's see what happens when I rotate on the Z. And a positive, it brings it in, a negative is away. So I got lucky. If you notice that a positive rotation actually brings your joint away from then you would need to select the opposite positive or negative direction than whatever it is currently. But because we figured it out, it's good to go. And then the wrist, I would consider also, it is going to bend in kind of a in a kind of this direction. So I think the Z is appropriate. So now we need to get these series of joints in line. And as I mentioned, though, I can't just move them, because once I move them, you can see the axis for its parent no longer doesn't follow it. So how do we get these joints into place? Well, one of the things that you'll also notice in joints is that they only have positional information. They don't have rotation information when they're set up initially, right? Like I can select all of these. None of them have rotation. Now, this is the way you want them, because what this actually, that's kind of a clue. So what this means is that we can actually use rotate and scale to get joints, the child joints, into position, because we can freeze those. You can't freeze positional data for joints. So like, watch, if I go to channels and I say freeze all funk, nothing changes. So if I just use the rotation and scale, I can actually get joints into place. So because this joint, our collarbone joint, is not dependent for its parent, which is going to be this joint, since it's not dependent on this axis. So its parent joint, the X is pointing towards the last spine. I can move this using the move tool because I'm not going to throw this alignment out of whack. But I can't do it with this one, as I've demonstrated. So what I'm going to do is I'm going to move this collarbone kind of into position. And now I think that's probably pretty good, but I got to get this shoulder joint in. And what I'm going to do to get the shoulder into place, I'm actually going to rotate and scale its parent. So I'm going to just rotate it back. And that looks pretty close to center. And then I'm going to just kind of rotate it down just a little bit. And again, I'm just going to be looking around to see if it's pretty close to the center of mass in this joint area. Looks like it might be a little far out this way, but I'm just going to scale it in. So if I want to move it in, I just scale its parent down a little bit. And you can see that it pushes or pulls its child joint out. And once I'm done with that, you can see now I've got all of this translate and scale data in the collarbone. Well, I can just go in and go to channels, freeze all, and it's gone. And then this elbow is into place. And you can see that because I rotated and scaled its parent, the X axis still is aligned to the shoulder. So now I'm going to do the elbow, and I'm going to use the exact same process. So in order to move the elbow in place, I need to adjust the parent, so which is the shoulder. So let's have a look here. I'm going to go to the front view. And I'm just going to rotate this up this way. So now you can see the shoulder joint, or the elbow joint, is kind of center of mass there. And now I'm going to go to the side view here. And it's kind of hard to see, but I'm going to move that right about there. Although for the elbow joints, I do try to get the elbow just slightly further back in the geometry. I don't try to go dead center with the elbow, just back a little bit, and we'll get into that. We'll get into why later on that one. And you can now see that I didn't really have to scale it. And actually, let me turn on my overlay here so I can kind of see how the geometry is laid out. It's pretty good, but I am going to scale it down a little bit. I'm going to bring this joint in a little bit by using the scale tool on its parent. And that looks pretty good. So, but now the shoulder has this additional rotation and scale. I have channels. I can do freeze all, but I also created a little tool here to do this for me, which is freeze transforms. So I'm going to click that. You can see them go back to 0. And now I need to get the wrist joint into place. So again, just using the rotate and scale on the elbows, I can get this joint into place. So I've rotated it pretty where I think it's probably pretty close. Now I'm going to flip the side views just a little bit easier. And I'm going to move that joint into place here. Oops, do a little bit of rotation. Again, try to get that center of mass. I'll pop over here and just see if that looks right. Cool. That looks pretty good. Again, I've got this translation data. I need to freeze the transforms. Done. And now I'm going to look at the wrist here. So the last thing I'm going to look at, even though there's a couple things you can do. You can create a Terminator joint temporarily if you wanted to help you align the wrist joint, but I think it's pretty valuable to kind of understand how your joints are oriented to the geometry. And actually, let's do that with the elbow first. So if I look at the elbow, actually, it doesn't look too bad. So if I'm looking at the geometry for this elbow area, specifically like the arm, so you can see like you have this plane of polygons that run down the front of the arm. That's kind of how this arm is going to bend. But if you look at the orientation of the elbow joint, you see how it's kind of askew. It's kind of off to the right a little bit. So I need to get this into alignment with the elbow so that when the elbow bends, the elbow will bend the correct way, because otherwise it's going to kind of bend off to the side. That's not going to work out. So I'm going to go ahead and rotate this to where it's aligned kind of to that plane of geometry right here. And that looks pretty good. Again, now I've got rotation data that I need to clear out. So I'm going to hit freeze. And then I'm going to double check my wrist, and that's in pretty good shape. Because I was only rotating this along the X, the wrist joint did not change position, which is fine. But now I got to do the same thing for the wrist, right? Because if I look at the hand, the hand kind of, you can see like where the knuckles are. They kind of follow this kind of orientation, but my Z is way off. It is way to the left. So I'm just going to rotate this to where it's kind of perpendicular to that plane. And you can actually see too, if I go to the side, it's also kind of, well, not so much for the side. You can see it kind of, this blue line, which is my Z axis, doesn't really point to that center knuckle, which is kind of the middle of your hand. So I'm going to rotate it this way a little bit to get it into position. And again, you just kind of look around and make sure that these axes kind of look like they're aligned as best you can. And I would say that's probably pretty good. Maybe a little bit out like this so that it's, again, like, you know, you've got your X axes here, your X rotation axes here. It kind of bisects the hand. The Z axis here bisects the hand. And so that should be pretty good. But again, I've got this X, Y, Z rotation data. I'll just freeze transforms and that's done. So now, despite this arm being pretty squirrely, I've got my joints for the arm laid out. And I know that they're all perfectly aligned, right? Because I did not use the translate or the move tool to move any of these. So I know that they're cool. Let's just say I want to go ahead and connect these up, the spine to the clavicle. I just select the spine, shift select the clavicle. I'll hit P and oops, sorry, the other way around. Select the clavicle, select the spine, and then hit P. And you can see then, because I parented them, you can see how you can see that bone connection now, which tells you that they're all connected. If I need to go in and start naming these joints. And so I'll select the clavicle, and I will go ahead and just select the hierarchy. And then I'm going to just go JNT underscore, and I'm going to hit enter. And what that does is it automatically puts in at least the first part, my prefix, which is fine. And unfortunately, all these are named different things, but my naming convention, right? You go from large categories to small categories. So it would be joint because they're all joints. That's the biggest category we've got. The next one would be left or right side. So left, let me actually hit the L. And then I'm separating these by underscores to make it easier to search and replace later. So joint underscore L for left underscore. And then this is actually just the clav. So I'll just leave it at that to keep it. Oh, there seems to be one there already. Let's find out. Clav one, or maybe I just didn't do that right. Yeah, apparently I didn't do that right. So joint clav, I can also rename these here in, so this would be left underscore shoulder. This will be left underscore. I could have used L when I did the rename. That would have probably saved some time, but and then left underscore wrist, enter. And so now they're all named correctly. I need to make sure, I think I already added them to my joints scene layer, but just in case I missed any, I'm going to select my root, select the hierarchy. I'm going to right click on my layer and say add selected objects. So now I know everything in there is, is in that layer. So we've done the spine, we've done the arm, and we're going to do the fingers the same way. So I'll just show you the fingers. Now the fingers on this particular model are kind of a challenge. So how you proceed with this is really kind of up to you. You can either do it from the front view and then just kind of lay them in that way, or you can do it the way I'm about to do it. It's up to you. You're going to have to go through the same process regardless, so it doesn't really matter. The thing that I do know is, at least if memory serves, when we did the arm, doing it from the front view gave me I think the alignment that I was looking for, but we'll see if that's the case. We'll see if I'm a liar here. All right, so, oh yeah. So when doing it the way I'm about to, you kind of, again, you have to take anatomy into consideration. So we're not going to create any joints for the center of the palm. The wrist is going to do all the heavy lifting for that. But we do need to create joints for each of the knuckles and a terminator at the end. So we have a knuckle there, and a knuckle there. So we're going to need 3 knuckles and a terminator, which makes for a total of 4 joints. And so in the front view, I'm actually just going to go to the skeleton, create joints. And I'm going to hold the shift key down when I create these so that it creates them in a straight line. So hang on just 1 second. Let me see, skeleton, 8 joints. Okay. Yeah, that's fine. So again, I've got 1 joint, 2, 3, 4. So again, holding that shift key down, I've created my 4 joints. I'm going to hit enter. I'm going to select those joints, and I'm just going to drag those radiuses down a little bit. Actually, I'm just going to set it to 1.5, so they're all the same size. Again, I'm going to turn on local rotation axes. because that's what I use to be able to see how they're oriented. Without these turned on, you're not going to know that. I'm going to pop back over to my perspective view. And if I select the root, or not the root joint, but the, the base knuckle, and I rotate that, right? So I'm pretending this is the finger, and I'm rotating the finger down like it would be closing into a fist, but I can see that's a negative Z rotation axis. Again, like we've talked about repeatedly, I want positive rotation values to bring body parts towards the center of mass and negative to bring them away. So this orientation is not going to work. So I'm going to go back to ye old trusty Orient Joint tool, and X is my primary. That never changes. Z is my secondary. And since I know that the positive orientation of this in the Z world Z axis gives me a negative rotation, I need to make this, I need to have it switch to the opposite world. This is very confusing to talk about, sorry. I need to basically have the Z axis pointing in the opposite direction that it is now. That's probably a better way of phrasing it, which in this case would be the negative Z world axis, which you can see right there. So again, right, X primary, Z secondary, and I want it to point in the world Z axis and in the negative direction. I'm going to say orient children because all of these are going to orient the same way. And I'm going to click apply. And you'll see how they all oriented except for the Terminator, because the Terminator, again, right, uses joints use their child for orientation. So for primary, secondary, so, or for primary anyway. And so because this one didn't have any children, it didn't orient, but I can click orient joint to world. And I'm going to click apply. And now they all are the same. And if I rotate my knuckle now, like a fist closing, you can see that it's a positive rotation. So now that we've created the joints, we've got them oriented correctly, now we can actually move them into place. Again, since this is kind of the root of the finger branch, so to speak, you know, there's no, there's going to be like 5 knuckles that go into the wrist, and we've already oriented the wrist. So we can actually use the move tool on the first joint only. And what I'm going to do is actually use, because it's this, I'm going to use the move tool, and I'm actually going to change the orientation to world. And the reason is initially because, well, actually, I don't even need to in this particular case. I can use object. But we'll talk about that here in just a second. So I'm going to just use this to move this joint to that first knuckle. And that's probably pretty good. Again, kind of center of mass there. It's probably pretty good. You want to try and get it in the center as much as possible. And so, but if I look at the rotation, right, it's straight up and down, and the knuckle is kind of this way. So I need to rotate the Z so that it goes along how that knuckle would bend, right? So you can see that now the Z axis kind of goes along that knuckle. And then I'm going to just kind of rotate this joint into place so that it goes along the length of the finger, right? And so I can see once I moved it in, it might be a little high. So I'm going to move this here. And then I'm going to start moving these knuckles into place. I'm going to use the rotate and scale. And since there's this, you can see that there's this V shape here for the knuckle. There's another V shape here for this knuckle. So that's kind of what I'm shooting for. So again, just kind of moving that. So this joint's kind of there. I'm going to scale it a little bit to push it into place. And then again, I'm going to look in the perspective, that looks pretty good. I'm going to select this next joint with the rotation tool because it's possible that the fingers are curved in a way that doesn't see, like, for example, like right here, it's still a little off. So I'm going to just tweak it a little bit, just right there. And then it's the same thing with this knuckle, right? I'm going to look to see, does this kind of line up? And it does. So now I'm going to move this knuckle into place by rotating its parent here. And then it's way too far out, so I got to scale its parent in to bring it in. And looks pretty good. And the Terminator doesn't have to be quite that far out. So I'm going to just drag it in just a little bit. But again, making sure that it's well clear of the geometry. And then again, just like going through and checking that rotation and making sure that it's, so like you can see, like here, it's a little, this seems a little off, kind of off this way. So I'm going to just rotate it so it's a little bit more centered. And look at it here to see, like, there we go. Look at this, just to make sure like this Z axis, Z rotation axis sort of bisects the finger joints. Then once they're in place, like if I look in the channel, there's rotation and scale. So what you can do is actually select the hierarchy and then freeze transforms. And now you've gotten rid of all the rotation and scale values, which is exactly what you want. You want those zeroed out. Again, the position or the translate values are always going to be there. And so again, I'm going to add those joints to my, whoops, wrong one. Right click and add selected joints to my layer joints. Then I need to rename them. And over here in the outliner, you can kind of see how they are set up. So I'm going to select my joint 1, shift select joint 4, use my renaming tool and call it JNT underscore left underscore index, because that's the finger. And then I'm going to say underscore, and I'm going to just leave it as that. Hit enter. And now you can see that index, it's blank. There's 1, 2, and 3. So I can actually just say index 0 if I wanted to. That would be fine. And then I will do this. The third one, that's actually the Terminator. So I'll rename that one. And now when I'm ready for my next finger, I am just going to make sure that I am recording. Okay, good. I'm still recording. I would have hated to go this far and then realize that I hadn't resumed recording. So again, I can select, if I want to do this finger, then I can just hit Shift D and it will duplicate the entire chain. But again, these fingers are really kind of weird. So they aren't going to be, just because you have one aligned doesn't mean the others are, right? And if I look at this finger from kind of straight on, you can see how it's not quite aligned. So you're going to have to go through and you can see the finger's definitely not aligned. You're just going to have to go through each one of these and move them into place using the same sort of process. So this one, I'm going to just kind of go through this so you can kind of see how it goes. And it's hard when you've got a lot of geometry going on, but just got to do your best. Try to be as precise as possible. And that looks pretty good. I'm going to rotate it down just a little bit. And that's probably pretty good. Again, it's sometimes really hard to tell. And then I'm going to go to the next joint, do the same thing. I'm not going to worry about freezing the transforms until I'm done with them that way, because I'm going to probably do a lot of adjusting. So again, moving this joint into place. That looks pretty good. And this Terminator joint's fine. So now I'm just going to look at the orientations of each of the joints. Again, I already looked at that first knuckle, and it looks pretty good. I'm going to just do this a little bit. I'll look at the second knuckle. Just make some minor changes here and there. Third knuckle. That looks pretty good. And this joint's coming out of the kind of the middle of the finger, so I think we can call that done. So again, I'm going to rename these. Now, one of the things I could do is change this to 0. Oh, I can't. Sorry. So again, I'm just going to go in and do the rename. Left instead of index, I'm going to say middle underscore, hit enter, and it follows the same thing. So I can just say 0 and then T. And you can follow this process for the other fingers. The thumb is kind of a weird one because this first joint is actually going to be down here. So I'm not going to go into that. I'll let you problem solve. I've kind of gone through this a bunch. So, and I think I've got a video on the fingers in particular. But now, of course, what we want to do is connect these fingers to the wrist. So you just select your index finger, the 0, hit the P. You can see that connection when it's made. I'm going to select the middle joint 0, shift select the wrist, hit P again, and now they're connected. And if I select both of these fingers, 0 joints, and I select the hierarchy, if I go into the rotate Z and I rotate them all on a positive, you can see that they all work the way they're supposed to. A positive brings them in, a negative brings them out. That looks painful. And that's kind of our joints. So now let's move on to our control. And I'll do this from the side view. So for your control, you're going to need something to designate this as a hand control. I'm going to do the hand controls for this guy. And so I'm going to say create curve tools. I'm going to use the EP curve tool, 1 for the curve degree, 1 linear, so that I make hard edges there. And I'm going to use I'm going to hold down the X initially to create my first CV on a grid point. Then I'm going to just kind of create a very rough hand icon. And then I'm going to hold the V key down again, or I'm sorry, the X key to snap to grid, and then keeping it held down, I'm going to close off that curve. I hit the enter key to say that I'm done. I'm going to move this over a little bit because I just didn't like how. So again, very, very rough hand shape here. And when you create one of these, its pivot point is going to be at the origin. And so what you can do is hit the insert key, which puts you in pivot edit mode. I'm going to hold the V key, or dang it, the X key down again. You can see the icon for the pivot change. And then I'm just going to, whoops, let me do it this way. Hold the X key, and then I'm going to just drag it up so that it's aligned with these two. And then I'm just going to move it over to roughly where the center is. When you're done, hit the insert key again. And there is my soon to be hand control. And I'm going to create another layer. And I'm going to call this layer, not surprisingly, CTRLS. And I'll make these hot red so we can see them pretty easy. And before I move this hand control into place, I want to create finger controls. Now, the way we're doing finger controls is to really learn a thing about Maya and how to create certain different kinds of controls. You probably wouldn't do finger controls quite this way, but if you need to create other ones similar to it for other things, you'll know how to do it. So what we're going to do is create a slider that will control the fingers eventually. And so the first thing that I do is, using a very similar process, I'm going to say create curve tools, EP curve tool, and holding the X key, I'm just going to create a box. Enter. So this is going to be a slider control. And so what I'm going to do is use these control vertices, hold the X, whoops, to snap it. Oh, actually, take that back. What I'm actually going to do here, this is actually going to be the slider. And again, right, when I create a thing in Maya, it puts the pivot point down here at the bottom. So I could either move it into alignment, but what for this we can do is use a shortcut and say modify center pivot, and it snaps it to the middle. So what we're going to do for this control is when the animator slides it all the way up, the fingers are going to curl, and when he slides it back, they're going to uncurl. So we want to limit how far this thing can go. We don't want it to be the animator just kind of drag it off into infinity. So we're going to go into our attribute editor, and in the first curve tab, we're going to, you snap into place. I'm going to go to limit transform or limit information. The y-axis you can see is the slider. And so I'm going to say limit y-axis. The minimum I want to be is 0. Maximum is 1. And now when I try and move this, it won't go any farther than 0, and it won't, well, let me zoom back a little bit. It goes to 1. So it can also move side to side. I didn't limit that, but that's okay. You could actually do that, and at least you know, like all the limit information is in there, is in the same place if you wanted to. So you could literally just go in and say, just 0 these out. And now when you select it, you can't move it. You can only move it up and down. You can't move it side to side. The only thing about that, though, is that when you limit that information in here, you notice that that axis isn't grayed out. So that might give the indication that something is broken. So I'm going to uncheck that. And I will pick this up here in just a second. I got a thing I got to take care of, as you probably just saw. Oh, maybe you didn't. But here's what I'm going to do. I will go ahead and select these channels. I'm going to right click and say freeze. I'm sorry, not freeze, lock selected. And now when I select it, you can see that, oh, actually it doesn't. I thought it, but maybe it's the rotation it does that. Yeah, so the rotation it grays out. But in any case, what we've done either way, apparently, is we've frozen this control so that it only goes on the y-axis. All right. And so the next thing we need to do is create the box that will give the indication to the animator that the extents that this thing can move.